Hello, everyone. So this is the second assignment in our function trig unit. And I'm on the second page of notes, which is a good introduction. So when you begin the study of function trigonometry, what you actually should do first is go and watch my trig tracer eraser video that explains where the graph of sine and cosine, the graphs of sine and cosine come from, and how sweeping out right triangles around the unit circle produces the graphs of sine and cosine when you look at and focus on the fluctuations of the vertical side of the right triangle, which is the graph of sine, and the horizontal side of the right triangle, which is the graph of cosine. So I strongly recommend that video. Watch it. I think it's a good introduction. Today's assignment will be pretty short. I think it's a good introduction to what we're going to do. So this again is the second page of notes. It is your goal in every problem when you're trying to graph a sine or cosine wave to identify the A, the B, the H, and the K in any particular given equation of sine or cosine. And they just happen to stand for certain things in the graph, and they tend to affect the graph in certain ways. So we'll start with the value of A. The value of A determines the amplitude. So actually the absolute value of A, as you see here in these two formulas, is the amplitude. What is the amplitude? It's the height of either half of the wave. So you cut the wave in half at what's called the midline, which by the way is the K value in your equation. And that's the height of either half is the amplitude. So we're going to identify these A, B, H, and K values in any particular given graph of sine or cosine. That's how we're going to study and graph, study the features and graph the 5 points that are needed, 2, 3, 4, 5, to graph a sine or cosine wave. So the value of B, and notice how B is factored out. It has to be written in that format. Affects the period. So the greater the value of B, the more compressed the wave becomes and the less the period becomes. And I forgot to say it, the greater the value of A, the more stretched out, the higher, the height will be on either side of the midline. So those are two things that affect the size of the sine or cosine wave. So A affecting the height, the amplitude of the wave, and B affecting how compressed a period is. So the greater the value B, the more compressed the graph becomes. The less the value of B, the more stretched and flatter the graph becomes. H and K are simply like shifting the graph off from whatever particular point. For sine, we start at 0, 0. For cosine, we start at 0, 1. Although you don't need to know that. You just need to know that it is shifting from the original graphs of sine and cosine. So that's a good start. And this is how you calculate the period. This is how you calculate the amplitude, absolute value of A. And then K is the midline. This is how you calculate the maximum and minimum value. And then H is used in determining points for the graph. So here's the graphing procedure. This looks very intimidating, although it's really very easy. It's one of these things where you got to kind of watch me because you really don't need to do these. You just need to get, I should say these two, you just need to get started with the pattern because this is all about patterns. So without further ado, we'll get started. This is your notes. And what I'm going to do is I'm going to take 6 problems and do them, 3 sine, 3 cosine, and then you'll have 6 to do also with the graphs of sine and cosine included. So you need to identify the A, B, and the H, and the K. So if you wanted to think in terms of that, what literally, if we were trying to match, this is really weird that I wrote that. but we are trying to match the A times sine of B times x minus h plus k. You have to be able to see all of that in any particular given sine or cosine. And are A, B, and H and K going to change? You betcha, as we go through this. So it's important that you do that first and that you correctly do that. If you incorrectly do that, it's all over. Okay, you cannot generate correct coordinates. And we're going to determine 5 coordinates by using patterns, okay, rather than crunching out this here. I'm going to show you a very simple way of getting the delta table, like the step for each x, and then how the y's work relative to the amplitude. It's very simple, actually. First, what you should do is calculate the period. So the period is 2 pi, just meaning that we're going to see one length of this over a length of 2 pi. Now recall, we have cut the unit circle and we've laid it as the x-axis. And each little mark is 15 degrees, each little scale mark, or pi over 12. That's very important. So the very first thing you want to do is to calculate the delta table. Now, why is it pi over 2b? Because it's a fourth of this. So each sine or cosine wave is cut into 4 pieces. So when we look at this, here's the first piece, second, third. Actually, I'm going to look at here. First piece here, sorry. Second piece, third piece, fourth piece. So there's 4 like amounts of delta x that we have to look at. And so that's why you take the period and divide by 4, because it divides it into 4 pieces. Anyway, when you do that, you get the pi over 2b. That's where that comes from. All right, so this is going to be pi over 2, b is 1. We calculate it. Now that's everything. This is huge that you do the delta table. Now, you can do these out, depending on sine or cosine. That's not necessary to do. What is necessary is to say, all right, pi over 2, what scale mark is that? And the way that you get that is you turn this into 12ths, 6 pi over 12. So it's a scale mark of 6. Let me back up a little bit. Just meaning that where we start, so you always start at hk with sine and ha plus k with cosine. You can use these if you want. They're quite confusing. So h and k are both 0. Now the reason I did this 6 is that we're going to, when we graph this, we're going to, so these are the scale marks I just wrote down. We are going to be on those scale marks. That's like how it skips, where the 5 points are going to be. Now, so when you fill in x, you need to fill in with the pi over 12. That means 6 pi over 12, 12 pi over 12, 18 pi over 12, 24 pi over 12. Okay, so you do need to go and reduce those. If you wanted to fill in with like 12 pi over 12, okay, but it's not reducing it. So you need to reduce and recall that it's just the fraction without pi. So 6 pi over 12, you're reducing 6/12. That's 1/2. 12 pi over 12, you're reducing 12 over 12, so on and so forth. 18 pi over 12, you're reducing 18 over 12. Now, what about the y's? So the y's are done in this fashion. The next one is a plus k. So a plus k is 1. The next one is back down to k. And then we have negative a plus k, which is -1, then back to 0. Do you see how that works? That's a pattern over and over and over. So we start at whatever this y value is. We go up by the amplitude, then back down to that y value, then down by the amplitude, then back up. And you see that right here. We start, we go up by that amplitude, then we come back down. Then we go down by that amplitude, then we come back up. And again, with each of the x's on the appropriate scale marks. That's it. You have the 5 points. Now you're ready to do the graph. And I'm only going to want you to graph those 5 points, and you should label your y-axis appropriately here. So the first one is a 0, 0. The second one is 6, 1, or pi over 2, 1. That's right here. The third one is pi 0, and then 3 pi over 2, negative 1, or 18, negative 1, and then 24. Now, what do? You have to think in these terms. Let me get my ruler here. Here's the midline, or my ruler is. So above that midline, we'll tilt it down just a little bit here. You have to shape it like a parabola opening upside down. Below the midline, you have to shape it like a parabola opening up, but it's all connected into a wave. So if I take this page back here, notice above the midline, it's opening down like a parabola. Below it, it's opening up. Every time you do a sine or cosine graph. So here, I'm going to make this like it's opening down, like it's a big, it's kind of stretched a little bit. And so this will continue. I'll put an arrow there. And below it, we have to make like it's a parabola opening up. You can literally think in those terms, although it's not. So you see here, opening up, opening down. That's the graph of sine done on graph paper. Now it's going to look probably a little bit different on your calculator. But if you wanted to do this on your calculator, I would kind of recommend degree mode, since I think that's like the easiest thing to do, or radians mode, it doesn't matter. But if you wanted to check it out, you would just go graph y equals sine of x. And then this is, you got to go to your table set. And so pi over 2, if you're going to do degrees, so I'm on table start. So table start should be 0, sorry. H is your table start. And then your delta table is this right here. Okay, so that's 6 scale marks, 90 degrees, 4 pi over 2. You just have to make sure, and I'm going to use degrees, which means my mode has to be in degrees. So hello, people. People, listen. If you set it up in degrees to make the x-axis degrees instead of radians, you have to put your delta table in terms of degrees. This is the delta table right here. It tells you how to set that second value. You got to do it. If you're in radians, then you do pi over 2. And I'll do both. So here's what the table looks like. And it's easy to see in degrees where you're at. You can also do radians, which I'm not going to do to save time. If you're going to graph, you got to do zoom trig, zoom 7, because the calculator has to know how to set the axes. And so you can see that it's kind of close to it. And it also, by the way, this continues forever. So we could go in this direction also. I'm not going to continue it. I have a little bit of the x-axis. All you need to do is 1 period. So this is 1 period, 2 pi. Because it starts going up here. Where does it start going up like that again? Out at 2 pi. Is the period always going to be 2 pi? No. What's always going to be true? What's always going to be true? You need 5 points on sine and cosine. That's always going to be true. Okay, number 2, sine of 2x. So we have to do the same thing here that we did to start with before. We have to identify the A, the B, the H, and the K. So we do not see any, I'll do this one more time. You have to see it like this. You do not see any H or K value yet for shifting. So the second thing you should do is calculate the period, 2 pi over absolute B. Absolute value means just make it positive. So can it ever be negative? It can. So we're going to see one cycle in a length of pi on the x-axis. So I told you as B gets larger, it compresses the graph this way. Okay, so count on that. All right, so delta table, pi over 2b. This will be pi over 2 times 2, pi over 4. This is 45 degrees. Okay, and that's 3 scale marks. How did I get 3? Because 3 pi over 12. Convert the pi over 12 from the 12s. 15 times 3 is 45. So that just means that once we start at HK, so that's where we're going to start here. Where do I get 0, 0? Because HK is the first point. You can do this table out. That's the hard way. I just show the pattern to get these really quick and then how to do this pattern-wise really quick. So it's a step of 3 scale marks. So 0, 3, 6, 9, and 12. So that means 3 pi over 12, which is pi over 4. This means 6 pi over 12, which is pi over 2. 9 pi over 12, which is 3 pi over 4, and then 12 pi over 12. I did that fast. And then the y's, okay, so we're going to go up to a plus k. Then back down to the midline, then down, and then back to the midline. So the only thing that's different about this is that it's going to be more scrunched. Okay, so we're going to go 3 up to 1. So it compresses the wave, and that's the critical thing. When I write the quiz for this, I'm going to make these graphing problems more about your ability to identify the changes in graphs based upon the A and the B. Okay, so I'm going to take like 2 or 3 sine equations. And I'm going to say, all right, this is sine of x. You have a sine of x, a sine of 2x, a sine of 4x. Or I'll throw some amplitudes in there. Like you have a 3 sine of 2x. How does this affect the graphs? And I think that's very important. And then these are used to model certain wave phenomena. And it's important to be able to apply them. That's going to be our last assignment. So 3, 2, 0, and 0. Again, I'm not going to write that down every time, but still at 0, 0 for H and K. So our pi over 2b, or our period next, 2 pi over b, is going to be pi. So you're doing 2 pi over 2. So we're going to see it within, compressed within 0 to pi. We're going to see our amplitude be 3, though. That's what's going to be different about this. So this is going to be pi over 4 again. So we had that from before. And remember, that's 45 degrees or 3 clicks. So we're going to start at 0, 0, and we're going to go by 3 clicks again. So a lot of times these have the same x value. So you can look back on previous problem to get them. A lot of students will just do the 0, 3, 6, 9. You do need to write this technically because that's what it is. That's the unit circle being cut and laid at the x-axis. So you need to be careful that you do it. So the second y value here is 3 because we do a plus k. A plus k. So now you just follow the pattern. You go up from the midline, then you come back down to the midline. Then you go down 3 and come back up. So when we do this, we have to label up to 3 and down to -3. It really is pretty easy once you get the idea. So we're going all the way up to 3, back down. So you see how the value of A stretches it vertically. So this is the same graph as before, just stretched vertically. And remember, above the midline, it's like a parabola opening down. Below the midline, it switches over, and it's like a parabola opening up all the time. So the midline in these problems has been the x-axis, but however you shift it off, it's whatever cuts that, it's whatever the k value is. This is the midline right here. All right, that's 3. Moving along, number 4. Now we're into cosine. It's the same thing. So we have 1, 1, 0, 0, 2 pi over 1, which is 2 pi. The difference is the starting point. So this is going to be pi over 2, which is 90 degrees, which is 6 scale marks. You see a lot of this is similar. It's just now your starting point is a plus k. So we start at 0, 1. That's the only difference here. And we have 6. Again, you can, 18 and 24. You can go and grab the old x's from previous problems. A lot of times that's going to happen. So this is pi over 2, pi, 3 pi over 2, and 2 pi. And then we come back down to 0, the midline, then -1, then back up to 0, then back up to 1. So it's the same thing, just shifted a little bit. How do you know which one's better? They're really the same. So 0, 1, and then do all of your marks and remember how to shape the graph. This one's a little bit more, so we're kind of opening down right here. And then we got to switch over. In here, we're opening up. So it's like a big fat parabola in there opening up. And then we're opening down over here. So it's a little goofier. You do have to think of the midline as like cutting two separate parabolas in half, although they're not, but you can think of it that way. So there's the graph of cosine. And then the last two, everything is the same. I'll go pretty quick on these. So there's A, B, H, and K. So 2 pi over 3, a little different this time, based on the value of B there, which is okay. So that means that we're going to see this in 8 clicks. So 8 pi over 12, meaning that it's like going to end here on the 8 scale mark. We're going to see the whole thing compressed in one wave from 0 to 8. So that B value compresses the graph. The A value stretches it vertically, compresses it horizontally, I should be saying. All right, so pi over 2 times B, pi over 6. So this is going to be pi over 6, which is, let's see, 30 degrees and 2 scale marks. So we're going to go by 2 scale marks each time. And the start will be 0, a plus k, which is 1. And then, so this is like saying 2 pi over 12, 4 pi over 12. So 2 pi over 12 is pi over 6. 4 pi over 12 is pi over 3. You do have to reduce. 6 pi over 12 is pi over 2. 8 pi over 12 is 2 pi over 3. So just reduce 8/12. That's the idea there. And then down to 0, down to -1, back up to 0, and then back to 1. It's really pretty simple once you get it. So 0, 1, and then just 2 click marks down to 0, and then 4 click marks down to -1. And then back to pi over 2, and then out at 8, we're up at, and so again, below it is like a parabola opening up, and then once we get above the midline, we got to think of a parabola opening down. So it's just getting your mind correct when you're drawing that. Don't give me straight lines. Oh, I'll go crazy all the way over here. No straight lines. This is about thinking of, you know, like the part that's opened up and the part that's opened down above and below the midline. Okay, last one. 3 cosine 2x. So 3, 2, 0, 0. Notice we did not have any values of, oops, this is 3 here, sorry. We did not have any values of, I don't know why I did that first, but 0, 3, of h and k other than 0, 0, which is okay. This is going to be pi, so 2 pi over 2. We're going to see it one wave scrunched in between 0 and 2 pi. So pi over 2b, this will be pi over 4, which is 45 degrees, which is 3 scale marks. So it's going to jump by 3 scale marks each time. And then again, you just need to go and reduce. So this will be pi over 4, This will be pi over 2, 3 pi over 4, and pi. And a lot of these repeat, so you can look back on old problems. Back down to 0. This will then be -3 up to the midline, and then back up to 3. So it comes back down to the midline, 0, and then goes below the midline, then back to the midline, then above the midline line of the value of absolute value of A. Okay, so the midline is K. Whatever K is, that's your midline. It could be something other than 0. We've just dealt with the ones that have been 0 because it's the easiest approach to start with. So up to 3, we have to go. 0, 3, and then 3 scale marks, and then 6 down to -3. It's really pretty simple. What I'll probably look at if I was you know, grading a graph that you were going to be sketching, I think on the quiz I'm going to have you match them. Is, are you curving it, you know, so below the midline, are you curving it up like a parabola opening up? Then once you get above the midline, are you curving it down? That would be a very big important idea of showing that change over and how it's curving. Even though like you're not graphing the whole parabola, if you think that way, you have to curve it, the curvature changes. So that midline is like called an inflection line, where the graph kind of inflects over into the opposite curvature. So you got to try to do that in each graph. So you have 6 to do for your assignment.